Hi everyone, and you are welcome to this lecture, Decorators in Python. In this lecture, I'm going to introduce you to an advanced concept which is decorator. So I will start by defining what a decorator is, then we will see how we can pass functions as arguments, how to define functions inside other functions, how to create a decorator, and how we can use multiple decorators together. And finally, I will end up this lecture by a quick summary. So let's get started. What's a decorator? Decorator is a way to add new functionality to an existing function without modifying its body. In other words, I want to update the function behavior without updating the body of that function. Now the question that rises in your mind, why I could need something like this? Let me give you an example. I will take as a use case authentication layer in a web application. When we develop a web application, actually we build some functions and then we call this function over internet using HTTP protocol. The point is that when your web application supports authentication, which means only authenticated user can use these functions, you have to add this authentication layer to all of the available functions. Which means if an authenticated user requests a function, the function will work properly. Otherwise, if the user is not authenticated, for example, the system should return a message that you are not authenticated and you are not able to use this request. You will note that this functionality authentication is one functionality that should be added to all my functions inside my web application. And in order to do that efficiently without repeating any line of code, so we implement authentication as a concept in one place and then we use it everywhere as a decorator. In order to understand decorators well, you have to know that everything in Python is an object, including functions themselves. Also, I need you to know that object is something that has attributes and methods are just simply functions, but we call them methods in context of object. To understand better about object, you have to learn about object-oriented programming in the future. Now let's move to PyCharm IDE in order to see some code examples. The first example I want to show you is about how we can pass a function as an argument to another function. So let me assume I have the following functions. I have a function, its name increase, it takes one parameter x and it returns x plus 1. Another function decrease, which takes x and returns x minus 1. And I define another function, its name call, it takes two arguments. One is a function and the other is a parameter x. Now inside call function, as you see here, I say function parentheses x. So I am calling this function. Why I am able to do that? Because I am assuming that I will pass here a function object. And because it's a function object, I can use it to call. So let's see now an example how we can use the function call. I will say x equal to 10. I will say y equal to call. And I will say increase, comma, x. Then I will print y. If I run this, I got 11 as you see here. Why this happened? Because here I am passing increase. So this function now it's increase. It will take x as a parameter and it will return x plus 1. So I will get 11. If you want to call decrease, you have to say decrease. And look here, I'm just passing the name because now I'm passing a function object. I don't want to call the function in this area. I need the function call to call my function. So here I am using parentheses. And in this case, I got 9. Why 9? Because 10 minus 1 is 9. And this is the first idea that you have to know in your way to learn about decorator. So you have to accept that in Python, we can pass a function as an argument to another function. Now, the second idea that you have to know that in Python, we can define a function inside another function. So here is an example. I will define a function, its name, say hi, and it takes one parameter name. Within this function, I define another function, its name only hi, and this function returns hi with name. Then inside the function say hi, I say result equal to hi, and there is no error. Why there is no error? Because the word hi has been defined as a function inside the function say hi. This function returns a string, and I will assign this string into result, and then I will return this result. Let's try now to use say hi function. So I will say x equal to say hi and then I will run using my name. So I will get hi Samir. So what happened when I call this function? I will enter to this function. I will find that here there is a function definition. So I will execute this part and then return the result. Now let's talk about the third concept before we talk about decorators. Let me assume I have the following function, its name greeting, and within this function I am defining two functions. The first one, say hi, the second one, say hello. And we already see something like this in the previous example, so we know now that we can define a function inside another function in Python. Because this function is an object, so we can return this function from the function itself. So look here, I say, if the word is hi, look here, this function accepts word as an argument. So if word is hi, I will return say hi. So what is say hi? Say hi is just a function. And here if I say if word hello, I will get return say hello, which is another function. We can understand from this example that in Python, we are able to define a function that returns another function as output. Now let's see what will happen when I want to call this function. So I will say greeting function equal to, I will use this greeting, and I will pass hi. According to my function, when the word is hi, I will get say hi, and say hi it's a function object. Because it's a function object, I can call this object. So I can say greeting function, and I will put here my name, for example, Samir, and run. Let me print. As you see here, I got hi Samir. Why this happened? Because greeting will take hi, which will give me a function say hi. When I call say hi, it will say hi Samir. Now if I replace hi by hello and run, I got here hello Samir. So simple. In Python, we can define a function that returns another function in its output. So to summarize these concepts, I will say in Python, we can pass a function as a parameter to another function. In Python, we can define a function inside a function. In Python, the function can return another function in its output. Now, after we know these three concepts, let's see how we can build a Python decorator. Assume I have the following function and its name divide, and it takes two parameters x and y, and it returns x divided by y. Let me use this function for example, divide 4 by 2. Run. As you see here, I got 2. What if I put here instead of 2, 0 and run? As you see, I will get 0 division error. Why 0 division error? Because in mathematics, we are not able to divide any number by 0. Now let's define a decorator which will add a new functionality to our divide function. This functionality is the following. If the second argument is not 0, I will return x divided by y. Otherwise, I will print a statement that the second argument, which is y in this case, should be a number different from 0. Let's see how we can do that. I will comment this part first and then I will print this part. As you see here, I will define a function, its name decorator, and this function take as an input another function. Inside my function, I want to define another function, its name wrapper, and it takes two parameters x and y, like my original function. Now I will check if y equal to 0, I will print the second argument cannot be 0. Else, I will return function xy. Why I say function xy? Because here I am passing a function object, so I am able to call this function. And once I have defined this wrapper function, I will return it from my decorator function. So to summarize, decorator is a function, accept a function as input, there is a function defined within decorator, and this decorator return this function. We can understand that wrapper will give me this statement that I want to be printed. Now, let's use division function now, or divide function with my decorator. I will say now print decorator and I will give my function which is divide, but here I will not put parentheses and I will take the output of this to be a new division function equal to decorator division, and now I will use this new division for x and y, which is 4, 0 in this case, and I will run. You will see now that there is no error happen and I got this statement printed. The second argument cannot be 0. Why this happened? Because decorator, which is this function, takes my function as an argument and give me another function enhanced by this functionality. Check if the second argument is 0 or not. And returns to me this function, which I use it here to print the value of 4 divided by 0. If I put 2, I will get 2.0. As you see here, in order to use the decorator, I have to use the decorator name, so I have to call it, then I have to pass my function. But there is another way which is very common to be used in Python when you want to use a decorator. So first of all, I will take my decorator here and I will define it before my function divide, the function that I want to decorate. And now I will say @decorator. When I say this at decorator, this means that I want to decorate divide function by this decorator. And now there is no need to do this at all, and it's enough to call your function. So I will say print divide 4 by 0 and run. And as you see here, I got the second argument cannot be 0. So this way is equivalent exactly to the previous way in order to use the decorator. Here we call this function as decorator function, and divide is the decorated function. In this example, we have seen how we can apply a decorator to a function. Now let's see how we can apply multiple decorators to the same function. So let me assume I have the following code, which is very simple. I have a decorator, its name uppering, and another decorator, its name lowering. And I have a function, its name getStr, and return a string, which is hiSummer. The job of decorator uppering is to call my function, to take this string and then converts the letter into uppercase. And the job of lowering function is to call my function and get this string and to convert all the letters into lowercase. Now, how we can use the decorator? As we see before, you have to say at and then the decorator name. I use now at uppering, then at lowering. Now let me use my function with and without the decorators. So if I comment these two decorators and run, as you see here, I got hiSummer, which is this string. Now, if I activate this part only, I will get hiSummer and all the letters are in lowercase. But now if I comment this part and activate this part, I will get hiSummer, all the letters, capital letter. What will happen if I uncomment these two parts? You will see that I got all the letter capital letter. And from this example, we can understand that when I have multiple decorators, the decorator nearest to my function will be executed first. So lowering will be executed first, then uppering will be executed second. And for this reason, I got hiSummer, all the letters in capital case, because uppering decorator has been used secondly. And that's all for this code session. Now let's summarize what we have learned in this lecture. In this lecture, we have learned about decorators, and decorator has been defined as a way to add a new functionality to an existing function without modifying its body. And we see this in an example of division, and we see that we are able to handle zero division without updating the original function divide. Also, we see how we can use the decorator, and we say if you want to use the decorator, you have two ways. You have to use the decorator as a normal function, or we use @ and then the decorator name above the function that you want to decorate. Now please refer to the file Decorators in Python Challenges, in which you will find some challenges to practice what you have learned in this lecture. Thank you very much for your time, and if you are available, join me in the next lecture.